Welcome children to this session again. In our previous class, we have seen about the Newton's three laws of motion, their applications and few examples of those. Today we are going to discuss about another concept of this lesson called momentum and law of conservation of momentum. See, these are the two concepts that we are going to look into today. Now, to begin with, let us discuss about the word momentum. It is a very common term, children, momentum. Any object which has got some mass and moves with velocity has this concept called momentum. Any object, the condition, it should have some mass and it can move some with velocity. It can move with some velocity, or even it can remain at rest. Momentum of a body is defined as, in simplest form, it is the product of mass and velocity. Momentum is defined as the product of mass and velocity. Momentum is equal to mass into velocity. Momentum is represented by P, children, is equal to M is mass, this is V. This is the formula to be calculated regarding momentum of an object. In this, momentum of any object depends on two factors, directly proportional to mass and velocity. Consider a scooter and a truck. Which one has larger momentum if both travel in the same velocity? Truck has got more momentum because mass of the truck is more than the car. Consider two cars. They have same mass but moving with different velocity. The car which goes with greater velocity has got greater momentum. Therefore, momentum of a body depends on mass and velocity. Definition part, formula part, then the momentum of a body depends on momentum depends on mass and velocity of objects. Therefore, SI unit of momentum, International System of Unit, as we know, which came into existence in 1960 in France, where they suggest a common scale of measurement. SI unit of this becomes, see, it is unit by heart, children. If you know the formula part, you will be able to write down the SI unit part. Mass is kg into velocity becomes meter per second. Meter per second. Therefore, SI unit of momentum is kg meter per second. In this, children, the things that you need to know, you must be in the position to define momentum. Momentum, it is nothing but is a product of mass and velocity. The formula part. Momentum of a body always depends on mass and velocity. We will be solving sums based on this. Then, another important part that we have learned this one, we are going to use this to prove second law of Newton in terms of momentum. Second law of Newton in terms of momentum. The rate of change of momentum is directly proportional to the plate force and takes place in the direction of force. This is about Newton's second law of motion in terms of momentum. We are going to see the definition part and the relation part. Children, we have seen the Newton's second law of motion. It gave the relationship between force, mass and acceleration. The acceleration produced in a body is directly proportional to the force applied and inversely proportional to the mass. We have given the statement form, and the formula it was F is equal to m into A. That was the formula. Same formula we are going to get in this also. The change is this, Newton's second law in terms of momentum. Let us understand this, children. Statement part, I will say it first. The rate of change of momentum. Momentum changes with time when external force is applied. The rate of change of momentum is directly proportional to the applied force, and change in momentum is in the direction of force. You will understand through this illustration, children. Listen carefully. A vehicle whose mass is m and it moves in this direction with the velocity. Therefore, I have taken initial velocity. This object, a vehicle having mass m, moves with some velocity. Let me consider this as initial velocity. When external force is applied on it, mass remains same, children, but the velocity increases. One of the effects of force, when effects of force we have seen, we can increase or decrease the speed of an object. It already is moving with some velocity. Therefore, using external force, we can increase the velocity, speed. Therefore, an object mass remains same, children. Mass will not change when force is applied, but the velocity changes. Initial velocity became final velocity. It moves in this direction. Now, consider this. Its momentum P is equal to P1 is equal to mass into U. Momentum. It is a product of mass into velocity. Its momentum, let me consider as P2, will be equal to mass remains same is V. Consider the two situations, children, don't get confused. An object of having mass moves with some velocity. Therefore, its momentum becomes m into u. When external force is applied on it, there is change in its momentum. Its velocity changes to v. Therefore, momentum becomes m into v. It was moving with some momentum. When external force is applied, therefore, its momentum is changed. Therefore, change in momentum, the rate of change of momentum is directly proportional to the force applied. Let me consider like this. Force is directly proportional to change in momentum. The rate of change in momentum. The rate of change in momentum or change of momentum. Remember, children, this can be written as force directly proportional to change in momentum means the rate of change of momentum means change in momentum divided by time taken. Remember the definition of acceleration, the rate of change of velocity. Rate of change of velocity means change in velocity by time taken. Rate of change of momentum is nothing but change in momentum divided by time taken. Change in momentum by time taken. Change in momentum means, see, the object, the vehicle Change in momentum means final momentum minus initial momentum. Change in velocity means final velocity minus initial velocity. Therefore, F proportional to change in velocity, change in momentum means final momentum minus initial momentum by again time taken, children. Therefore, let me consider this in this way, children. F, let me keep as it is, proportional to final momentum. We know it is m into v minus, this is initial momentum, is m into u divided by this time taken. Listen carefully, children. Now, F proportional to m is common, children. Therefore, this becomes v minus m is taken out, u by this t. Consider in this case, m remains same. V minus u by t is nothing but acceleration, the rate of change of velocity. From that substitution we have to take v minus u by is equal to a. This is how we get F is equal to m into a. Proportionality sign is taken, is equal to k into m into a, where k is nothing but a constant. We have seen in the second law, k is a constant, is equal to 1. Therefore, F is equal to m into a. I repeat, children. Second law of Newton in terms of momentum. The definition says, statement, the rate of change of momentum is directly proportional to the applied force, and change in momentum takes place in the direction of force. Object moves with mass, moves with some velocity. When force is applied, its momentum changes. That means mass remains same, velocity changes. Therefore, its momentum is m into u, its momentum is m into v. Momentum has changed. Therefore, change in momentum is directly proportional to the applied force. Force directly proportional to the rate of change of momentum. This is written as change in momentum by time taken. Change in momentum means final momentum minus initial momentum. Okay, final momentum is m into v, initial momentum is m into u. M is common, children. Therefore, v minus u by t. This v minus u by t is nothing but an acceleration. So, this is about Newton's second law of motion in terms of momentum. Children, we shall look into the next concept, law of conservation of momentum. Law of energy we have seen. It says energy can neither be created nor be destroyed, but it can be transformed from one form to another. In this case also the same. Momentum is conserved, that means remains same. The total momentum of a system, remains conserved, which means remains same, provided no external force acting on them. It says the total initial momentum of two objects will be equal to the total final momentum of those two objects. Consider mass m1, mass 1, first object. This is the second object. Its illustration, children. We are going to prove it now. Its illustration. Two objects I am going to consider, mass 1 and 2. Before collision, let me consider this as a truck, this as a car. Truck has got different weight, mass, and car has got different mass. Therefore, Truck mass 1, car mass 2. Truck moves with velocity, initial velocity u1. Car moves with initial velocity before collision this one. The truck comes and collides with the car, then after collision, the mass of these two vehicles will be same, but the velocity changes. The mass of the truck remains same, but the velocity changes to v1, final velocity of the truck. This is the initial velocity of the car, it is changed to v2. So, this is total momentum before collision. Total momentum after collision. So, total initial momentum is equal to total final momentum, which means to say the total momentum remains conserved. The total momentum remains same, provided no external force acting on them. Its explanation and the proof, children, we are going to do it now. Don't worry. What is this truck, this is car, what is so you need not to worry about this, children. Now we are going to prove this. Children, in the theory part, we are in the last stage. This seems to be the last concept that we are going to learn in this lesson, children. Then followed by sums and exercises part we are going to do. In this, we are going to prove the total initial momentum is equal to total final momentum. Law of conservation of moment. Okay. This, the derivation part, children, you have to take a long sheet and you have to practice it at least twice or 3 times. This is easy one. There is a link between each step, children. You can understand it easily. Listen carefully. See, before collision, after collision, there are 2 vehicles, truck and a car. They move in the same direction. The truck whose mass is m1, car mass m2. Mass will be different. Therefore, m1, m2. Truck moves with some velocity u1. Car also moves with some velocity u2. Therefore, this is initial velocity of the truck, initial velocity of the car before collision. The truck comes and collides with the car. Then, after collision, what happens? The mass of the truck remains same m1. The mass of the car also remains m2. But there will be change in their velocity. Therefore, the velocity of the truck was u1, it became v1. So, initial velocity of the truck, final velocity of the truck. Initial velocity of the car, final velocity of the car. Therefore, the momentum of the truck becomes m1 u1, product of mass into velocity. Momentum of the car is equal to m2 u2. After collision, the momentum becomes m1 v1. Momentum of the car becomes m2 v2. This is the basic concept. Now, the second part. Both the vehicles moving in a particular direction having some mass and velocity. The truck comes and collides with the car, therefore there is change in the velocity of the car, of both. There is change in the velocity. When there is change in velocity, we say that acceleration has occurred. Therefore, acceleration is nothing but the rate of change of velocity. Therefore, acceleration produced in the truck A1 is equal to its final velocity becomes v1, initial velocity of the truck. We are speaking about truck, children. Therefore, about the truck acceleration. v1 is the final velocity of the truck, u1 is the initial velocity of the truck. You will get time taken. Similarly, acceleration produced in the car. I have taken A2. Therefore, you have to speak about car now. The acceleration of the car, which is nothing but this is U2, this is V2. Final velocity minus initial velocity by t. Acceleration of two vehicles we have written. Next, as per the Newton's second law of motion, see how many concepts come in this. As per the Newton's second law, F is equal to m into A, the force exerted by the truck on the car, F1 is equal to, on the car it is, therefore this is mass of the car, acceleration of the car. This m relates mass and acceleration related to car only, children, remember. Similarly, force exerted by the car on the truck, this will be equal to F2, this is M1, this is about mass of the truck, acceleration of the truck. Now, we come to the third law of motion. See how many links are there. We know that third law states, for every action, there is an equal and opposite reaction. Therefore, children, F1 will be equal to minus of F2. Equal and opposite reaction. Therefore, minus. F1, let me write. What is this F1? This is M2 into A2. M2 into A2 is equal to minus of F2 is equal to M1 into A1. M1 into A1. Now the substitution part, children. M2 remains same. A2 becomes here A2. V2 minus U2. V2 minus U2 by T, this will be equal to minus M1 into A1 becomes here V1 minus U1 by T. V1 minus U1 by T. See, children, it's easy to remember. 2, 2, 2, one side, 1, 1, 1, one side. This is also another simplest thing you can remember. But you have to understand and create step by step, children. T and T get cancelled, children. Therefore, the remaining T and T get cancels. Therefore, M2 into V2 minus M2 into U2. Multiplication of binomial and the monomial. M2 into V2 minus M2 into U2 is equal to minus M1 into V1 minus into minus becomes plus M1 into U1. Now the last statement, the step, children, M2 V2, let it be here only. Let me take this towards this step, because final velocity and all the V's together, all U's together. V's together and U's together. Therefore, this becomes, when transpose takes place, minus becomes plus. M1 V1 will be equal to, this is M1 U1. This goes that side, transpose, therefore plus M2 U2. The final one, M1 U1 plus M2 U2 will always be equal to M1 V1 plus M2 V2. So, this is what we have written just in the law of conservation of momentum. The total initial momentum is equal to the total final momentum. So, this is the formula, children, we need to understand. It looks a bit lengthy, but it is easy, children. You have to take a long sheet and slowly proceed one by one, one by one, one by one. There is a link between each step to each step. Okay? vehicles I have taken, their mass is different, then the velocity also different before collision. After collision, mass remains same, velocity changes. Then acceleration produced by the truck, acceleration produced in the car. Then force exerted by the truck on the car, the force exerted by the car on the truck. As per Newton's third law of motion, for every action there is an equal and opposite reaction. Therefore, F1 will be equal to minus of F2. Substitution and the simplification part, children. So here we end the theory part. In our next class, we will be doing the sums and the exercise part. Thank you. Have a nice day, children.